In this video, we present EvoGraphDice, a system that supports evolutionary visual exploration of multidimensional datasets characterized by a large number of possible views or projections. EvoGraphDice combines visual analytics with stochastic optimization to help guide user exploration towards interesting cells in an interactive, flexible and adaptable manner. The user evaluates cells, and the system learns from this the type of visual pattern the user is interested in. The main visualization window of EvoGraphDice consists of a scatterplot matrix where the original data dimensions are organized as rows and columns of the white quarter of the matrix. The white cells show all possible bivariate projections of the data. EvoGraphDice uses an interactive evolutionary algorithm to suggest new interesting views to the user. These are displayed in the remaining quarters of the matrix in yellow background color. In this quarter, the user can investigate if a visual correlation exists between a new combined dimension and an original one. The proposed dimensions are linear and non-linear combinations of the original dimensions, and their values are initialized using principal component analysis. The algorithm learns from past user interactions in order to progressively evolve new interesting viewpoints. Only the best views are selected based on the complexity of the combined dimension, the amount of visual pattern in the view, and user evaluation. To demonstrate how EvoGraphDice works in practice, we will run through an example. We synthesize the 5-dimensional dataset with two enclosed curvilinear dependencies between variables x0 and x1 and random data for the rest of the dimension. We will now try to evolve a scatterplot where it is possible to separate the two curves, i.e. the dependency between x0 and x1, with a straight line. This task is equivalent to separating the two convex hulls of the curves. The first generation of suggested dimensions have values that are automatically calculated by principal component analysis. Let's evaluate some of these views. Our criteria for evaluation in this example is purely visual. The smaller the overlap between the two colored areas, the higher the score should be. By pressing the Evolve button, the algorithm will try to learn over a few generations the type of visual patterns we are interested in. The new views have been assigned a rank from 1 to 5 by the system. We can correct these evaluations if we do not agree with them, or simply reassign the rank for reinforcement. Cells that are evaluated by the user are flagged with a small black square. If you find an interesting cell, you can add it to your favorite cells by selecting that view, then clicking on the Favorite toggle button. Selecting a view from the Favorites list highlights the corresponding cell in the matrix, or brings it back if it has been replaced. A good solution to this training example has now been found. EvoGraphDice provides a dimension editor that allows the user to modify an existing combined dimension and dynamically see the effect on the data. The user can also choose which dimensions are going to be combined by configuring the search space of the evolutionary algorithm. After this, a system reset is required, similar to pressing the red button on the left-hand side of the interface.